Alright guys, welcome back. We're going to be solving another question from the Dynamics in Engineering Mechanics by Meriam, and we have 180-pound man in the boson's chair that exerts a pull of 50 pounds on the rope for a short interval. We need to find his acceleration, neglecting the mass of the chair, rope, and the pulleys. And one thing that we need to assume in this question is that all of these ropes are parallel to each other, so there is no angle in these ropes, which in the question, if I look at it, this one looks a little bit oblique. So let's just try to figure out the forces in here. So first of all, we have a cable or this rope that is attached to the hand of this guy. I'll just show it like that. So the pull is in tension, which means the man is feeling that tension upward, which we know the tension is also 50 pounds. So that's the direction of the force that is applying to the hand or the hands of this guy. So we can solve this question in multiple ways. Uh, Obviously, we can just try to do a section in here and draw the free body diagram for the man and the forces that are applying to him. So let's just do that. So basically we have, so my drawing is not the greatest. So let's just assume that this is the guy. So we have this cable that is attached to the bottom. So let's just consider one single tension in here, which we need to figure out what's that tension. There's also another tension that is pulling his hands up, which is basically what I explained here. So 50 pounds in here too. And on top of this, we have the weight of the man, which is also 180 pounds. So this is pretty much all the forces that we have for this guy, but let's just see how we can figure out this T. And for finding that T, first of all, we have one single cable. I'm going to show it in red. So we have one single cable that goes around this pulley, goes around here, goes around this pulley. So it's one single cable, which we know the tension in it is 50 pounds. So every single point of this cable or the rope, the tension would be 50 pounds. What I'm going to do in order to find this force T in here, so we have this pulley, I'm going to show it in here, which 3 cables are attached. In here, basically the tension for all of them is the same. I'm going to call it T1 just to differentiate these forces. And here we have another tension, which is basically the T that we called in here. And each of these T1s are basically 50 pounds because, as I said, it's a one single cable, so each of them are 50 pounds. And the cable is always in tension. We cannot consider a cable in compression. That's why each of them are upward too. So if we just do and since we are moving, so we need to figure out the acceleration of this guy. So the sum of all forces in this direction is basically mass times acceleration. Obviously the mass that we have in here is the mass of the rope and the pulley in here, which from the question we can neglect that. So this will be equal to 0. And if that's 0, the forces that we have is basically 3 times 50 minus t is equal 0, which t is 150 pounds. All right, so now we figure out that this t is actually 150 pounds. And now we're going to do sum of all forces for this free body diagram. And I try to color code each equation with the free body diagram. So here we're going to do the same thing, sum of all forces in y equals 0. 150 plus 50 minus 180 is equal to mass times acceleration of gravity. So the mass that we have is the 180 pounds, which is weight. So we need to find the mass. We know weight is mass times acceleration of gravity. Based on the units that we have in here, our G is 32.2 foot per second square. So it's not 9.81 because these are not SI units. So this is going to be 200 minus 180. So 20 is equal to 180 divided by, so mass would be W divided by G, so 180 divided by 32.2, that's going to be the acceleration. Let's just do it A or AY, it doesn't really matter. So A would be basically 20 times 32.2 divided by 180, which is going to be 3.58 foot per square second. And as we can see, it's positive, which means the acceleration is upward, so demand is going up. Everything was clear. I tried to be as specific as possible in this question just to figure out all the forces that we have. I got some question from you guys that all these forces were confusing, but I think this breakdown also helps with the tension in the cable and what free body diagram we should use for this. Everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.